Hello, Internet! Yeah, it's me, Albert Einstein, coming to you straight from the theoretical beyond to explain why time is a lot weirder than you think. So, let's talk about relativity. Imagine you're in a train, and inside that train, you toss a little ball straight up in the air. To you, the ball goes up and comes right back down. Easy, right? Now, imagine I'm standing still at the station watching that train speed by. From my point of view, the ball curves through the air because the train is moving forward while the ball goes up and down. So who's right? Both of us, because everything depends on the observer's point of view. In 1905, I published what's called special relativity. It describes what happens when you move really fast, close to the speed of light. And that's where things get strange, but very real. First, time slows down for an object in motion compared to someone who's standing still. That's called time dilation. So if you went on a space trip traveling near the speed of light, you'd return to Earth and find that everyone else aged a bit more than you did. Second, mass and energy are the same thing. That's where my most famous equation comes in. E equals mc squared. This formula says that a tiny amount of mass can become an enormous amount of energy. Boom! 10 years later, in 1915, I published General Relativity, a deeper and more complete theory. Now I was tackling something much bigger, gravity. Until then, gravity was thought to be a mysterious force that pulled objects together, but I proposed something completely different. Gravity is the curvature of space-time. At large scales, there's no real difference between gravity and acceleration. Imagine space as a giant sheet. When you place something heavy on it, like the sun, the sheet bends. Planets like Earth are simply rolling along those curves, like marbles orbiting a ball placed in the middle of the sheet. The sun isn't pulling us in. Space itself is curved. And that curvature tells planets how to move. So, was any of this proven, Einstein? Of course. Some of it while I was still alive. Other parts? Not until long after I died. Let's see. 1919. Astronomers confirmed that starlight bends near the sun just like I predicted. Yep, happened during an eclipse observation. And that's the young me. 1970s and beyond. Scientists measured time dilation using atomic clocks on planes and satellites. Today, GPS satellites actually adjust their clocks based on my theory so they don't get off by miles. 2015, scientists detected gravitational waves, tiny ripples in space-time from black holes colliding. I predicted them back in 1916, but hey, that's a story for another video. So, yes, the theory was confirmed. It sounded crazy at first, even to me, but the universe proved me right. And why does this matter, Einstein? Because relativity changed everything. It's used in modern technology like GPS. It's the foundation for understanding the universe on a massive scale. It opened the door to modern physics, black holes, theoretical time travel, and the idea that space and time can bend. But more than that, it showed that sometimes, to truly understand the world, you have to change your frame of reference. If you've made it this far, congratulations. You now understand the essence of the theory of relativity, explained by me. As I always say, imagination is more important than knowledge, for knowledge is limited, but imagination embraces the entire world. Danke schön. And until next time.